Chapter 8. Network load balancing provides scalability and fault tolerance in a server cluster, a group of servers responding as a single IP address. This is how it is possible to handle more traffic by adding more servers who still respond to the one request. So we have our client machines connected to a network. Whenever they ask for any information out of this IP address, any one of these three will respond because they are all in a network load balancing cluster. They don't have any special hardware requirements. All the participating servers should not be providing services other than whatever the cluster is providing, because otherwise that's going to become confusing to the boxes. NLB should be installed on each server who's going to be part of this cluster. Each server should have 2 NICs, one for communicating with network clients and the other one for members. And of course, you can add this in Server Manager or PowerShell. So in this example, we have 2 switches. One switch that would be facing outward to our clients, and the other one where our cluster communicates with each other. Doesn't have to be 2 physical NICs. It could really be 1 NIC, and we have a VLAN where this dedicated communication is happening separate from these guys. Any number of array can be done to achieve this same goal. To create a cluster, it takes a couple of steps. I got to create our cluster, got to give it, select the host, set any priority and host IDs, set that cluster address, and then add all the other servers. There is the network load balancing manager within Tools and Server Manager where you can create the new cluster. Again, you must specify a host, and you would enter the server name. Once it's connected, it'll ask what network interface will be used in the cluster. So that's the one that will communicate with the outside world. Here it looks like it's Ethernet in this example. You can have up to 32 servers in a single cluster. And you can choose the priority value depending on, maybe you have different servers with different CPU and memory and different levels of resources. So you can choose to have maybe the first server be the one that's most beefiest and just go in descending order, or the other way around. However you choose, you can give them priority. You'll set the virtual IP address. That's the one that any of the hosts will respond to. You'll need a DNS record on your local network. If you have 2 NICs, then the cluster address will replace the one that will be facing out. Now you'll need an FQDN. And then you can choose which way the cluster will operate. Will it be unicast, which is the default, multicast, or IGMP, multicast? And there's the options. Your port rules will say which ports will be handled by the cluster and how that traffic will be distributed among all the members. The higher the load weight, the more traffic that a member will handle. So here's the port rule. No priority was set, no load was set in this example. Once all that is done, now we can add more members into our NLB, which again, they have to have the feature already, and then you can add their interface and a priority. So here we are with our new cluster, and we're going to add another host by right-clicking. And again, the cluster is the configuration of the cluster is in 3 parts. And like you saw, you would right-click and then go to the properties, which you'll have things like the IP address and other parameters that you can set. In most cases, you will want to set the port rules to accept communication on the cluster address only, because that is the whole point of that cluster. And those port rules will apply to all hosts that are in the cluster. So you only have to set it in one place, and it'll take effect everywhere. Your filtering can be multiple host or single host. The host with the highest priority will handle all the traffic, or the traffic will be load balanced between everyone. You also have the affinity value of any cluster could respond, the request from the same client directed to the same cluster host, or a single cluster will respond from a specific IP network. So you have different ways of handling the traffic coming in and out. And you do have host specific properties. If you right click a host and hit host properties. It'll show the cluster's IP address, any parameters, and port rules. You can use the port rule tab to edit any of the port rules that aren't set to disabled. Once that's all done, then you'll need to perform maintenance, of course, because nothing is set and forget, which you'll do within the NLB manager. You can control a single host through this manager, so you don't have to go to the individual systems. So here you see from this panel, we can start, stop, drain, stop, suspend, or resume as we need. To upgrade a cluster will require taking the server offline, doing that upgrade, and then bringing it back online. So it's not something that can be done on the fly. It is something you would have to schedule out and prepare for and plan when you have the lowest amount of traffic, so that you can have more servers down, do the upgrade, and bring up without affecting your clients or affecting connectivity. You have some items here to keep in mind, like verifying all the clusters support the new version that you're upgrading, using drain stop on each host before you begin the upgrade, and then set the initial host state to stop, and then making sure all services work after the upgrade before bringing it back into the cluster. So upgrading is not as straightforward. It's going to take a few steps, and it's going to require some manual work. And there is a table, and I'm sure you can simply Google to get the list of commands that you could use through PowerShell. Now, failover clusters are used for high availability. This is well suited for your mission critical applications, things that must stay on always. We can cluster applications like a web server. We can cluster a complete server. We can do active nodes, passive nodes, and standby nodes. Here are some terms that Microsoft uses in this realm. We have the quorum, the database containing the configuration and status of each node in the cluster. We have the heartbeat, providing the status of each node, and the witness disk, a shared storage to store cluster information. Obviously, with failover, you need at least 2 servers, and both of them should have identical configuration. Both of them should also have access to a common storage media, like a SAN. So if one server goes down, they're able to communicate through the SAN or be able to tell each other and be able to continue that mission critical service no matter what. So again, we have 2 or more servers together using shared storage to provide fault tolerance and high availability. Our client computer can see a failover cluster as a single entity, since it doesn't need to see how many servers are running. All the servers will have access to the application data. So in case one fails, another just takes over. Passive servers will know when an active server is no longer able to work through the quorum process, which basically just checks the cluster status. And if it sees one of the servers going down, then the passive server could become active without you having to set the switch on. It can do it automatic. There's different ways, different models that you can employ this. And they're listed here, like the node majority, the node and disk majority, node and file share, no majority, and cloud witness, where we're using the cloud and not just on-prem systems. Again, your requirements should have at least Server 2016. They should be identical or nearly identical to each other with the same architecture. You should have separate adapters to communicate to storage and separate for network. So you should have at least 2 NICs. Should be in the same domain. And any apps or services should be the same version number. Your storage should be, again, available to all members. It's required if you use the disk majority or the no majority. And you should have digitally signed drivers connecting your storage together. Installing it is through either a wizard or through PowerShell. You can perform the verify step before installing the feature to make sure everything is ready. Everything works, everything connects. Then you would run the validation wizard, which is the failover cluster manager added to the admin tools after you install the feature. You install it'll prompt you for names and other settings to set up and to test. This is what the failover cluster manager looks like. Once it's installed and verified that the system can be in a cluster, then you'll set up the cluster itself. and making sure that it has an IP address and DNS entry is in, that it is in Active Directory and all that kind of stuff. Once the cluster is created, you'll have a few more tasks to do. It's definitely not a one-step setup. Then you'll connect the cluster networks. Again, you should have at least 2 separate networks. But if you are able to do more, then awesome. And ideally, you want to have them communicate separate from everything else by having different subnets. Since a lot of, especially the cluster communication can be very chatty for heartbeats. So it is good to have an alternate network for that communication only. Since any delay in a heartbeat can cause an effect of starting up other systems, and it could cause some mayhem as long as it's not set up right. You can configure the quorum model if that's the way you choose. And again, it has a wizard. The cluster storage. Again, all the systems in the cluster should be able to access it. So that'll definitely need to be added. Has a number of benefits of using the cluster storage. Again, by having this in place, you definitely have some benefits of minimizing bandwidth and quality of service. Having the network and file printer sharing so that adapters can carry that cluster communication. And really having it separate from everything else. So this is one of those essential traffics that you want always to work. Then you can go into the failover cluster and set up your roles as needed. Setting up your client access point. Of course, the role has to, or the feature has to be installed in every server that will be part of this cluster. You can do cluster aware updating, which is an automatic software update to maintain availability, and it's a simple process to enable that. This will help with Windows Update. Like I said, this is part 1 of 2. So let me hit stop to this.